This is the start of Chapter 7. Chapter 7 deals very heavily with ratios. What a ratio is, it is a comparison of two quantities. It's a comparison of two quantities. We're comparing two things specifically by using division. Now there's three ways to represent it. I can either say comparing A to B. I'm comparing A to B using a colon, or I could set it up like a fraction, A over B. That's the using division part of it. Ratios can be, and ultimately we want them to be, simplified. That's the ultimate goal of a ratio, is to be simplified. So an example here, a music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones in stock. Write a ratio in simplest form. Well, trumpet violin, we have 40 trumpets, we have 24 violins, and we can reduce that just like we can reduce any other fraction. So this is going to simplify to 5 over 3. Actually, let me write it like a ratio. This simplifies to a 5 to 3 ratio. What about flutes to clarinets? I see 51 flutes to 39 clarinets. And we always want to do it in the order that it's given to us. So when it says flutes to clarinets, the flutes comes first, the clarinets come second. This simplifies to a 17 to 13 ratio. What about trombones to trumpets? I see 16 trombones. I see 40 trumpets. That's going to be a 2 to 5 ratio. And now violins to total instruments. I see 24 violins, and let me add this up. 40 plus 39 plus 24 plus 51 plus 16. There are 170 instruments here. That is going to simplify to 12 to 85 ratio. Again, the whole goal here is to get them in simplest form. Extended ratios is a comparison of 3 or more quantities. So extended ratios, we're going to see them written like this: A to B to C. Not in questions 5 and 6, but here in 7 and 8, see 4 to 7 to 9, or 11 to 2 to 5. Those are examples of extended ratios. So how can we solve these ratios situations? I'm going to show you actually 2 different ways to solve these. One of them is quicker and easier, but the other works in more situations. So they both have their place. The ratio of 2 complementary angles is 3 to 7. Find the measure of both angles. The first way to solve that is, what do these guys have to add up to if it's complementary? And what a 3 to 7 ratio means, think about that. It means I could do 3 to 7, 6 to 14, 9 to 21, so on and so forth. Really, as long as I'm multiplying both numbers by the same amount, then I'm okay. That's what I'm supposed to be doing. I need to multiply 3 and 7 by the same amount. So if I do 3x plus 7x equals 90, that would work, because whatever I multiply 3 by, I'm going to multiply 7 by the same amount. Ultimately, it's going to add to 90. So let's solve for x. So if x equals 9, then the measure of angle 1 is 3 times 9, which is 27. And the measure of angle 2 is 7 times 9, which is 63. That is, and if I did 27 over 63, that would simplify to 3 over 7. Now, let's look at a second way to solve this. And I'm going to solve this using what I call part over total. This way is a little bit trickier, but it is going to help us out in the long run, especially this way of thinking when we get a little bit further on into this chapter and the way we do ratios with triangles and other shapes. So part over total. For measure of angle 1, how many total parts do I have here? I have 3 for angle 1, 7 for angle 2. 3 for angle 1, 7 for angle 2. So angle 1, there's 3 out of 10 total parts. Why 10? Because 7 plus 3 is 10. Equals, now the second fraction, I want to scale this up to however big I need it to be. My total number of degrees in this scenario is 90. And then what I could do is I could put an x there. So really what it's saying is I want these two fractions to be equal. Now the way to solve this is a process called cross multiplication. Cross multiplication. Very simple. This works when I have a fraction equaling a second fraction. What I could do is I can multiply one diagonal, so 10 times x is 10x, equals the other diagonal. So 90 times 3 is 270. Some people call it the butterfly method because it kind of looks like a butterfly when you draw it out. And when I divide by 10, I get x equals 27. Look familiar? Then if I wanted to do angle 2, I could do, angle 2 has 7 of those 10 parts. And in total, we're still going to equal 90. So I could do, after I cross multiply, I get 10x equals 630. I divide by 10, and x equals 63. So part over total, I can get both angles doing that. 3 of the 10 parts for angle 1 gives me 27. 7 of the 10 parts gives me 63 for angle 2. Let's do this ratio way. Sorry, the part over total way for question 6. And I think it's always good to write out part over total because I don't want to do 4 over 1. 1 is not the total. Don't make that mistake. 1 is not the total. So part is 4, the total is 5. If two angles are supplementary, how many out of 180? Now I could cross multiply. 5x equals 720. So x has to equal 144. So I know the measure of angle 1 is 144. Now I could do the exact same thing. 1 over 5 equals x over 180. And that would get me angle 2. But there's no need because I know they have to add to 180. What's going to add 144 to 180? That's going to be 36. Those are my two angle measures. Now the other way to solve it, if you so choose, would have been 4x plus x equals 180, which means 5x equals 180, so x is 36, and our two angles are x and 4 times x. So either way you choose to solve it is fine. I'm not going to tell you which way. But again, I think the ratio way is going to help us, especially further down the line. You'll see in the second half of the lesson. Let's do the short way on this one. The ratio, the measure of the angles is 4 to 7 to 9. Find the measures of the angles. So what do we know about the angles of a triangle? They got to add to 180. So I can do 4x plus 7x plus 9x equals 180. So that's 20x equals 180. So x has to equal 9. Measure of angle 1 equals 4 times 9, which is 36. Measure of angle 2 is 7 times 9, which is 63. And measure of angle 3 is 9 times 9, which is 81. There we go. That's all three angles. How about this one? The angles, the ratio is 11 to 2 to 5. I just want to find the largest angle. I don't need to find all three of them. Now, if I want to do that, I absolutely can. Nothing wrong with that. I'm going to solve this one with the part over total way, though. So the largest angle, just the biggest one, has 11 parts out of 18 parts. 11 plus 2 plus 5 is 18. Equals how many out of the 180 degrees? That's really all the ratio is. If it has 11 of the 18, how many would it have out of 180 if we multiplied it up? So now we cross multiply. 11 times 180. And actually write this out. 11 times 180 equals 18x. And you'll see why a little later in the lesson, why it's a good habit to get into to do that. So I get 1,980 equals 18x. And so x equals 110. There it is. That's our biggest angle. Oh, and then we did 18 times x. Let's do this one the short way. I'll just kind of keep alternating here. The ratios of the measures of the sides of a triangle are 2 to 8 to 9. The perimeter is 76. So I know this ratio has to add to 76. 2x plus 8x plus 9x equals 76. So that's 19x equals 76. And so I get x equals 4. So side 1 equals 2 times 4, which is 8. Side 2 is 8 times 4, which is 32. And side 3 is 9 times 4, which is 36. What do you think is going to happen if I add those three up? We're going to get 76. Now, if we wanted to set up the ratio, I won't solve this one all the way out, but if we want to set it up, side 1 would be 2 over 19 equals x over 76. Side 2 would be 8 over 19 equals, I'll say y over 76. And side 3 would be 9 over 19 equals y, equals, I'll call it z over 76. I would just do it 3 times, once with each part of the ratio, part over total. Let's do this one with the part over total. The ratio is 10 to 15 to 6. The perimeter is 217. Find the shortest side. Well, the shortest side is 6 out of those 21 parts. 6 out of 21 equals how many out of 217? I cross multiply. 21 times x equals 6 times 217. So I get 21x equals 1,302. And I get x equals 62. So there we have it. 62 out of the 217 is for the smallest side of this figure. Now let's look at proportions. And actually, that part over total, that was an example of a proportion. A proportion is an equation that states two ratios are equal. So a proportion is exactly what we just had. A over B equals C over D. And for any proportion, you can cross multiply. That's what we just did, multiplying across. So let's cross multiply here. I have x times 2, so 2x equals 7 times 4. Again, write it out. I know we're starting easy, but you'll see in the next question why we write this out. So 2x equals 28, therefore x has to equal 14. Question 12. Again, cross multiply. 6 times 13 equals 19 times x minus 1. Here is why we write this out. Because when we have a number multiplied by something with a plus or minus sign, we have to remember, think back to Algebra 1, to distribute. So we get 78 equals 19x minus 19. Remember to distribute. That's 97 equals 19x. This one ends up being a funky fraction. We end up getting 5 and 2/19 equals x. Moving right along. Again, you are going to cross multiply. 17 times 19 equals, write it out, 5 times x plus 4. So we get 17 times 19 is 323 equals 5x plus 20, because I have to distribute. So I get 303 equals 5x. So 6.6 equals x. Okay, we'll do another one. Here's one we're going to have to distribute twice. 7 times x plus 16 equals 6 times 3x plus 3. Distribute the 7. Equals 18x plus 18. Then we do some algebra. This one ends up being another funky decimal. Actually ends up being 8 and 6/11. About 8.45 or 8.54-ish. Okay, this one is very difficult. I am going to preface this one by saying if we have a situation like this on a test or quiz, we are going to have a practice day with this kind of algebra first. But let's start just by the setup. 5 times 27 equals x minus 1 times x plus 5. 5 times 27 is easy. That's 135. This part here, remember, go back to Algebra 1. One method was to FOIL it. First, outer, inner, and last. And when we combine like terms, we get. I've also seen people use the area method, or some people call it the box method, where we have x minus 1 and x plus 5. And then we combine like terms, we still end up with that x squared plus 4x minus 5. Either way, that's where we end up. Now, for algebra purposes, what should we be thinking when we see x squared and x at the same time? When we see x squared and x at the same time, that means we should automatically know to factor. Now, when we factor, rule number one is we must be equal to 0. So I need to subtract that 135 over. Second piece of factoring, I call it the morning method. There's other methods. There's the X thing. I've seen people use that same area method or box method to factor. I use what I call the morning method. You could use your own method if you have a better one that works for you. I'm looking for two numbers that are going to A, add to positive 4, and M, multiply to negative 140. What two numbers are going to add to positive 4 but multiply to negative 140? Well, what I'm thinking is positive 14 and negative 10. So my factors are x plus 14, x minus 10. Those two add to positive 4, multiply negative 140. The last step to factoring is equaling both of your factors to 0 and solving them separately. So I get x equals negative 14, and I get x equals 10. Again, this was a very difficult level question on the algebra side. At this moment, I only really care about the setup and you being able to cross multiply. If we have questions that are going to require you to factor, we will have a factoring practice day in class first. Let's get into a word problem. A quality inspector inspects a random box of 50 tablets. He discovers 2 are defective. In an order of 2,000 tablets, how many are likely to be defective? This is a real life situation. This is think about like when we went through COVID. They said if we test 1,000 people, how many are positive? Okay, now what if there's 1,000,000 people? How many do we think are probably going to be positive? That's exactly what this is. So I think the best way to start this is to write out exactly what two values you're comparing. We're comparing defective tablets over the total number tested, which means I can set up a ratio and write this out. This will save you from making silly mistakes on a test when you actually write it out. With 50 tablets tested, 2 were defective. With 2,000 tablets tested, how many are defective? That's exactly how we set up a ratio from a word problem. So we cross multiply. 50x equals 2 times 2,000. 50x equals 4,000. And so I get x equals, I believe it's 80, but let me double check that. 800. So we would be likely to see 800 defective tablets. That can't be right. It is 80. So we would expect if we tested 2,000 tablets, 80 of them would have a problem. Let's look at scale factor. Same basic idea. Think about a map. If you look at a map, you should usually see that little scale, like 1 inch will tell you how much it's really worth, like 1 inch is worth 6 miles or 10 miles or whatever it is. So that's exactly how we can use scale factor to help us determine distances on a map. Let's say the scale factor is 1 inch to 4 miles. That means the values we're comparing are inches and miles. Always write out the values you're comparing. If 1 inch corresponds to 4 miles, 7 inches means how many miles? That's what this question's asking. We can cross multiply, we get x equals 7 times 4, which is 28, so 28 miles. What about this one? 1 inch corresponds to 1,440 feet. So now I'm comparing inches to feet. If 1 inch is 1,440 feet, 3 inches means how many feet? So I cross multiply, I get x equals 4320. So 3 inches would represent 4,320 feet. So that's the basics behind ratios. We will be using these ratios throughout this chapter.